Oh my gosh, it's time for more? Does she ever stop? No, I can't. You need to learn. Hi. Hey, how about you hit that like and subscribe? Maybe one day I'll actually have lots of likes and subscribes and I'll be shocked. I'll be sitting there thinking, I didn't know it would work. I don't think that will happen, but that's okay. So, we're going to be kind of talking about a couple things here. It's going to kind of connect what we're doing now, if you've been following along, to our next section. So if you kind of look, if you go back in time, we talked about just like sustainability, that's the big overarching idea that we really need to understand. We need to be a more sustainable society. And I mean, what we learn in this course explains what's going on in Earth and advocates for us being a sustainable society. So the first things we talk about are sort of like just general Earth processes, so we can get an idea of why is climate the way it is, why does wind happen where it does, when it does, and why does it cause weather in the manner it does, what's going on with the Earth and geologic processes. And today I am going to talk to you a little bit about soil and soil formation, and soil composition. Man, I really want to do that lab with you guys in person. Maybe when things are more normal, we can do that. And like we'll just make some time and we'll get some stuff together and we'll just do it. And life will be good. And we won't write our reports. We'll just do it just so that way you guys get the actual experience of doing it. Wouldn't that be great? It would be great. Okay. So, this is taken from chapter 3 in your book. We're going to kind of just go over some kind of quick ideas. I'll talk to you a little bit about soil. Chapter 3 does mention a little bit about soil, but we're really only going to look at like 3-1 for now. I just want to make this point for you to see about an example of natural capital degradation, so loss of our natural capital. This is a tropical rainforest. Since I was a little girl, so that was a while ago, just saying, there have been like cartoons. I remember a cartoon called Captain Planet, Tiny Toons. They would all talk about, we have to save the rainforest, blah, blah, blah. I'm not going to say how many years, okay? Because maybe some shows were on before I was born or whatever, but like they were making cartoons in the 80s that were like, hey, stop polluting. Guys, stop destroying the rainforest. That's bad. Kids, you should care about this. It's 2020 as of making this video. I know, the cursed year. Okay. This is still going on. So, I mean, this was, 2003, because this is an older picture. Sorry, my head was covering it. But this is not getting better in some areas. Remember, I think it might have been in 2019. Remember when the biggest thing we had to worry about was the Amazon rainforest was on fire, and it was a terrible fire, and like it was like terrible and like terribly terrible and really bad. Remember guys? So people were like, well, we got to put the fire out. Well, it wasn't like a natural caused fire. People caused the fires. And they wanted them because they were burning the trees in the forest down so they could graze their cattle. Again, go back to the idea of tragedy of the commons. They wanted more grazing land because they could make more money if they have more farmland, if they have more cropland, if they have more grazing area for like cattle. And that forest is just there. If I just take a little bit of it, it's not going to make that big of a difference. That will cause a really large loss of biodiversity. Like there's animal species that go extinct, like practically daily. We get a lot of different resources from trees that really grow in the rainforest, like medicines and stuff. So This is something when people are like, stop destroying the rainforest. Yeah, that's important. We need to stop that. We have to. Okay, so let's just kind of look at this really fast. Hey, you? Are you alive? Yeah, you look. Yeah, you look alive. Well, what's keeping you alive aside from like maybe like a Monster Energy drink or a Tim Hortons coffee, or some food and 3 hours of sleep and your cell phone? Anyway, so there's four major components, and we've kind of talked about them a little bit already, actually. The atmosphere, air, the hydrosphere, which is all the water on Earth, the geosphere, so we've talked about the formation of rock, and we'll get to soil and sediment, and the biosphere, we're part of that, we're living things. And life is sustained by the flow of energy from the sun through the biosphere. That's where we get our energy. And the cycling of all the nutrients. So, like the carbon cycle, and the water cycle, and the oxygen cycle, and the phosphorus cycle. All those things connect those non living parts of Earth to the biosphere. That's so cool. And, like, we get our energy from the sun. We're like solar powered in like a weird way. Isn't science cool? It really is. So let's look at these components. We have our atmosphere, which we talked about before. The lowest layer is the troposphere. That's where all the weather happens. It has all the air that we're breathing. It's mostly nitrogen, then oxygen, and then the rest, the other 1%, are the greenhouse gases. So water, vapor, CO2, methane, and other trace gases. That's what our atmosphere is made up mostly. And then in the stratosphere, that's where you have the ozone layer. And thank goodness. Thank you, ozone. That's O3, by the way, if you wanted to write the chemical formula for ozone, it's O3. And that filters out 95% of the radiation that would hit us on Earth, which is great, because guess what? Ultraviolet radiation damages DNA. That causes things like cancer. That's where they're like, put on sunscreen, cover up if you go out to the beach, because you don't want skin cancer. The hydrosphere is all the water on or near Earth. So that means lakes, rivers, streams, ponds, the water vapor that's in the air, it's in ice or in the permafrost, it's under the ground in groundwater. I wonder if it counts all the water that's in all the living things too. I'm going to go ahead and say yes. Then you have the geosphere or lithosphere, that's like the crust. And that's where soil is formed and created through different processes. Actually, I'm going to plug my own channel. This is the first time I've done this. Oh, I'm so excited. You should check out my video that I made that's called Ecology Succession. Oh man, I should put a link in the description. I got to figure out how to do these things. I'm excited. So you should check out my video on succession, because that explains how bare rock can be colonized by things from the biosphere, by living things. And in there, it's just kind of mentioned, I'll mention it more in this video, is how soil is formed. It's formed from living things, not always living things, but it's formed from the weathering and erosion of rock. Okay, and then here's our biosphere with all our living things. So in this course, we're really looking at the interactions between all these four major systems and humans' impact on these major systems, and why is it this way, and what can we do? So just hope that you're kind of getting the big idea here. So just here's our general structure of Earth. I mean, we've talked about this, the core, the mantle, and here's the crust. Look at the tiny layer that is the crust. It's like nothing, right? Yeah, it's super tiny. Like the Earth is big and not flat. Okay. You can unsub if you don't unsub. I need you. But you can unsub if you think the Earth is flat, because it's not. Okay. Anyway, the crust is very, 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 very tiny and thin. Remember this part, mantle here. The upper part of the mantle plus the crust is known as the lithosphere, and that large moving part of the mantle with the convection currents is called the asthenosphere. The whole geosphere is actually considered the crust, mantle, and core, because it is. Here we have our atmosphere and the hydrosphere. This picture, this little slice, doesn't show the hydrosphere. It does, sort of. It's the clouds, water vapor, but it's showing a piece of land. And then it shows the biosphere, living things in here. So let's talk for a minute. How do we get this soil that's above the rock? Because last time with the rock cycle, we talked about how rocks are made. They can be made in a variety of ways, but let's just say here we had some igneous rock formed. Well, where did this soil come from? Well, soil is just weathered and eroded rock. So different processes will break down rock, and it will break into smaller and smaller pieces. So you have this giant bedrock under here. You can have a glacier come scrape over it and like crack it into like another large piece. Or you can have like wind and water battering a mountain and a boulder fall down. Okay, so a boulder would be like sediment. Or you can have like wind constantly blowing and water rushing over these rocks, breaking them into small pieces like sand. And then the finer pieces are then silt and clay. So soil is made of just tiny pieces of rock and dead material, like dead living things that have been decomposed, so their nutrients are in there. Like plant matter and roots and stuff is in soil as well. So you have this inorganic rock and you have organic material from dead living things that can form like some healthy soil. So there's a lab that I want to do with you guys eventually. You can do it on your own at some point. I'll make another video and show you guys how to do it on your own. But you can actually tell the composition of your soil, how much sand, silt, and clay is in your soil, just by kind of getting some soil and getting rid of all like the, I don't know, like the plant bits, adding it to some water, shaking it up, and letting it filter out, because it'll filter out by weight, basically, and by particle size. So the smallest particles will take the longest to filter, and then the heaviest particles will go to the bottom. And so the biggest particles are sand, and then you have your silt, and then clay. If I'm wrong, then I really will get the editor to come out here and fix it. But yeah, so it'll settle out. So you'll see like bands, and then you'll be able to tell like what percent each layer is worth. And then you can tell the composition of your soil from that. So soil is formed by just weathering and erosion of rock, and living creatures dying and being decomposed in that soil. Look, life is great. This is why biology is great. There's so many beautiful and diverse living things that we can't see with our eye, things that change, things that depend on each other. Oh my gosh, like there's so much. Life is so diverse, and we're here thanks to the interaction between all the geochemical cycles that go on Earth and the energy of the sun. It's great. So how do we sustain this biosphere then? Well, there's a one-way flow of energy. Okay, really. So it starts at the sun. Plants, come here, plant. This is totally a real plant. Plants will take it into their leaves and do that cool photosynthesis thing that they like to do and turn it into an organic compound we call glucose or sugar. Then that gets into other living things because we eat plants, or we eat the guys that eat plants. And then we lose some of that to the environment as heat. So we use our energy to grow and develop, and we also lose some of it as heat. And then some of the sunlight energy is radiated off into space. And then we have the nutrient cycles, which we'll talk to. And then we have our gravity. Thank you, gravity. Thank you, physics. That's not my favorite science, though. I think it goes biology, earth science, chemistry, physics. Sorry, physics. Sorry, physics. But gravity, thank you for existing, holds our atmosphere onto our planet so we don't lose all those gases to space. Then we really wouldn't be here. So the sun is a star. It is? Yeah, it is. You knew that. I'm just teasing you because you knew that. Okay, it gives off ultraviolet radiation, visible light, infrared energy. So it's giving off lots of different types of energy. And so what happens to the solar radiation? Well, some is absorbed by the ozone and other gases like ultraviolet radiation. Some of it gets just absorbed by the earth, like by the ocean, or just by like the Earth itself. Some is reflected. So remember, energy, like matter, can't be created or destroyed. It can change forms. So kind of like light, you can imagine, like just will get absorbed by things. Like my dark colored shirt might absorb more light and heat. Or if I have something really shiny and reflective, like my phone here, it can reflect some of that light back. And then some is radiated off by the atmosphere and lost as heat. So there's a natural greenhouse effect. That's a good thing. And that stores heat energy here on Earth. So we don't lose it instantly. So we don't just instantly ice over every time like the Earth rotates. So other planets like Mercury, for example, so close to the sun, it's when it's facing the sun, the portion that's facing the sun is hot, like hot. And then as it rotates, or the portion that's not facing the sun is freezing cold. That must mean there's a part of Mercury that's like not quite in the sun, not quite totally in the shade, like maybe it's like twilight right there, that maybe like you could like stand there on Mercury. We're gonna have to go look this up. We're gonna have to ask a physicist. Does anyone know a physicist that can tell me the answer? I would love that. Anyway, we've talked about the angle of the sun hitting the earth and how that makes the earth heat unevenly and how that can affect winds and climate on earth. So we've kind of talked about that. I just want to show you guys again. I think I'll post up on Google Classroom my favorite video about the greenhouse effect, which I think explains it so well. I'm not going to mention it here because I don't want to spoil it. I think I'll post it up there for you guys when we talk about the greenhouse effect. But here's how energy flows to the earth. And I think we did kind of mention this. We have our sun. We have some light and heat that's absorbed by earth. Most of that UV light is absorbed by the ozone. Good job, ozone. Some of it gets reflected by the atmosphere back off into space. Some of the heat that we do absorb ends up getting added higher up in our atmosphere, moved around by winds, or radiated and lost. But the greenhouse effect keeps some of that in. Good greenhouse effect, natural greenhouse effect. You don't want the kind that's like on Venus, where the clouds are so thick. That's why Venus is the hottest planet. Okay, the clouds are so thick. When the sunlight comes in, all that is absorbed and very little is radiated and lost as heat. So can't visit Venus. That's I guess why we're going to Mars. Elon, take us to Mars. Hurry. We got problems. All right. That's all I wanted to talk about, and I kind of gave you a little bit too about like, oh, okay, here's how soil is formed. And so if we were here in class, we would take the time to actually like get some soil, look at it, touch it. Like you have to kind of feel it too, because sometimes when you're deciding, is this like a loam? That's one of the soil names. I'll show you guys in class the little triangle. If you're trying to decide, is it like a sandy loam or is it a clay loam, you can actually make it into a ball and feel the soil and see, does it feel gritty and sandy? Does it feel smooth? Does it stick together? Does it just fall apart? And these are ways you can tell what kind of soil you have. Why is that important, Miss Olive? Well, if you're trying to grow anything in the soil, you should know what kind of soil you have to work with. And that will tell you all things like how quickly water is going to flow through there. This stuff is like totally interesting. It really is. And it's got practical uses. That's why I love it. I love it. All right. Well, I feel like I've been videoing a lot today, and this might be it. At least that's it for this video. Make sure you smash that like button. What does that guy say? Give me a thumbs up doodle. Make sure you like and subscribe. Or just subscribe. Or just hit the thumbs up. That way you actually know when I make a video, especially if you're in my class, just subscribe. You can subscribe with your school email. I don't think I'll get in trouble for saying that. That way it'll come to your email when I make a video, and that way you'll know, oh, something's coming up. You can always watch ahead of time instead of getting behind. These are life tips. These are tips that didn't exist when I was your age. All right, I'm going to go because I'm just rambling. It's like real life. All right, bye.